So guys, it's our first meeting for our MSD. So the first thing we need to do is to come up with a title, because that's what our supervisor asked us to do. Right guys? So thank you firstly. Thank you for coming to this meeting. And I would appreciate if you guys would focus to what I'm trying to say here, guys. And you?
Yes, I'm listening. Yeah.
Come on guys. Need something. We need a title for our project. That's very important. You know, our supervisor Dr. Shakir is very important. He wants us to know.
Yeah, alright, yes, I heard it. Oh my god.
Macam Adrian, where are you, Adrian?
What the hell? You think Chinese people glow in the dark, huh?
Whoa, it's so hot inside. Guys, I'm gonna go take a walk. Whew, thank God it's windy outside. Oh, it's so windy, ni. Oh gosh, what the hell? What was that? Dude! What happened there? There was something there.
Whoa, wind power generation.
The energy crisis is continuing to rise steadily. The reserves of fossil fuels which our entire economy and livelihood are overly dependent on is finite, and will soon be depleted. Therefore, the most responsible and sensible course of action is to transition to a source of energy that is renewable. One of the least utilized energy sources in Malaysia is wind energy. This is due to the low wind speed in Malaysia, which according to the weather reports, the most feasible location for a wind turbine farm in Malaysia is in Terengganu and Sabah. The wind speeds are generally from 7 to 13 km per hour, and 10 to 12 km per hour respectively. So, consistent amount of energy can be expected to be generated in this location. The main purpose of the project is to design vertical wind turbine system for usage suitability within the scope of Malaysia, and to be used in the rural areas. But, how does it work?
The vertical axis wind turbine, or VAWT in short. The Savonius model is very crude and was already used by the Persians 3,500 years ago. Then there is the Darius model, with blades revolving around a vertical shaft. Each blade gets hit by the wind at a different angle. They make use of an airfoil design, so they generate lift to make the turbine rotate. A generator at the bottom of the structure converts the kinetic energy into electricity. The VAWTs are omnidirectional. They do not need a yaw mechanism to be pointed into the wind. Also, compared to horizontal turbines, VAWTs can be grouped closer together, because they can operate in a turbulent and gusty wind. So why don't we see more VAWTs then? Well, VAWTs tend to be less reliable and less efficient than horizontal turbines. This makes them less suited for large-scale energy production. But the field is still under development.
Now, let's get to the design. The calculation is started by setting up average initial value for the performance of wind turbine, with wind speed of 10 meters per second. Then, parameters such as swept area, solidity, rated blade speed, and power available from the wind can be calculated. In this video, the design is focused on the wind blade, gearbox, shaft and the generator. So, the 1-meter wind blade is designed following NACA 012 blade type, with GI sheet with wooden frame material, which is suitable for the low wind speed condition in Malaysia. The shaft is then designed as so in order to hold the blade, having a DIN 6923 M12 hexagon flange nut. Also, the shaft is designed with a triangle rotor. Then, it will be connected to the gearbox, designed to have a planetary spur gear drive, ratio of 5:1, which means, the sun gear makes 5 revolutions, for each revolution of the output carrier. This planetary gearbox will connect to a spiral bevel gear set, in order to convert vertical to horizontal axis to suit the generator design. Finally, the generator is calculated to have 30 kilowatt induction motor, and is a DC type, brushless electric transmission generator. The gearbox and the generator will be contained inside the design container or nacelle, which is shown here. Here is the detailed exploded view of the whole wind turbine components as well as the complete view of the whole design.
Okay guys, the light is back on. Let's continue with the meeting. Okay. Adrian? Adrian?
Oh yeah, what's up?
Alright, Adrian, good morning.
Yeah. Oh, it's morning already.
Yeah, apparently. So, I need your opinion for our MSD project title.
I just had a crazy idea. Dude, this is what I was talking about. Wind turbine.